All right, this is our fourth and final day of 831, and really this lesson today, this problem, rolls right into 832, and we're going to be spending a lot more time practicing this. So today is just an introduction for finding all exact roots of a given polynomial. Now, we already know some things about this polynomial. We know the degree is 3, so we know the shape. We know it's either an n or a backwards n, okay? We know that it has a positive orientation, so on the right side it ends by going up. It's not in factored form, so we can't tell exactly what the intercepts are, but that's kind of our goal today. So when it says find all exact roots, the very first thing you're going to do is you're going to plug this into your calculator and you're going to look at the graph. And if you don't have a graphing calculator at home, go to desmos.com, type this in, and you'll see this graph pretty clearly. Now what you're going to see on the graph is that it crosses where it looks like about 2, it looks like pretty close to 0, and it looks like in between -3 and -4. Okay? And to confirm that it actually crosses through 0, we're going to go to the table, that it crosses through 2. We're going to go to the table, we're going to go down to 2, that says 2, 0, so we're good to go. If I thought it maybe crossed at 0, I would check, but this says 0, -2, so that is not an x-intercept. So I have confirmed on my calculator one x-intercept, and that's 2, 0. And you guys now know that if it's 2, 0, it means that it's going to be x minus 2 as one of my factors. Now my job is to figure out what's the other factor. And the way that I do that is I'm going to use polynomial division, and that's what we've been working on in lesson 831. So I'm going to divide x minus 2 into my original polynomial. So I'm just going to check it off. X cubed goes in the box. Up top I get x squared minus 2x. Draw the line. I need a positive 2x squared. I have a negative 2x squared, so I better add 4. Whoops. Going a little too fast. Okay, and x times what gives me 4x squared? That's a 4x. 4x times -2 is -8x, but I really need, check, -7x, so I better add 1x. X times 1 gives me 1x. 1 times -2 is -2. -2 already matches. That means it is a factor. By the way, if we see that it crosses at 2, then x minus 2 better be a factor. If I don't get a 0 here, then I need to go back and figure out where I made my mistake. Okay, so this is x squared plus 4x plus 1. Okay, so what we just did was we used the graph, we used polynomial division, and now what we have is a factored version of the original polynomial. Okay, how do we find x-intercepts from factored? We use the zero product property. Okay, and really that first one is unnecessary because we already knew from the graph x was equal to 2. Okay, but how do I solve this one? If I have x squared plus 4x plus 1 equals 0, you might think, well, let's try box and diamond. That would be a great thought, but it is not factorable. So remember, when it's not factorable, we have to use the quadratic formula. 16 minus 4 all over 2. Okay, now here's where in the next lesson we're going to want to be careful and see if these are real or imaginary. Because the 12 is a positive number, it's for sure going to give me two real solutions. If this was a negative number, it would give me two imaginary solutions. We also already knew it was real because we can see where that graph crosses the x-axis 2 other times. That means this has 3 real roots total. Okay, 3 real roots total. So, you can leave your final 2 answers like this. You could simplify if you really wanted to. -4 plus or minus 2 root 3 over 2. -2 plus or minus root 3. If you leave it like this, you're just fine. That's 2 solutions. This is the third one. We've answered the question. Find all exact roots. Exact just means don't plug this in the calculator and give me a decimal. Leave it as square root of 12. Or again, if you want to simplify it, you can.